Before we discuss the problem how to find the solution to the differential equation, let us briefly discuss the existence and uniqueness problem. More theoretically oriented people, if they have a problem, ask first the question, does this problem have a solution? And if so, is this solution unique? Is there just one solution or more? And the answer to these two questions provides the existence and uniqueness theorem. It goes this way. We will consider the differential equation y derivative is equal to some expression containing x and y, and let us denote the expression on the right just with the letter small f. The assumptions, the conditions are, if the function f, which is on the right of the differential equation, and its partial derivative with respect to y are continuous in the rectangle AB Cartesian product CD. Let me explain what the Cartesian product is. AB is some interval of real numbers, a segment on the real line. CD is another rectangle, another interval on the real line, but another. Let's sketch these two lines as two perpendicular axes, and if AB is this interval, if CD is this interval, then the Cartesian product of these two sets is the set of all pairs, where the first member is from here and the second member is from this interval. So, geometrically speaking, if this is a segment here, if this is a segment here, then the Cartesian product is the rectangle formed by these two intervals. We have open intervals, that means the endpoints do not belong to the set. So the boundary of the rectangle is drawn with the dashed line, meaning the boundary does not belong to the set. So we want f and its derivative, which are both functions of x and y. In all these points in this set should be continuous. So if this is true, then for every x0 from AB, say this one, and for every y0 from CD, say from this one, these two values specify one point in this rectangle. Then for any point in this rectangle, there exists a solution to the differential equation, and this solution is unique. There is just one solution going through this point to the differential equation. Y derivative is f of x and y, with the graph running from the boundary to the boundary. Well, and not just any solution. Solution satisfying the initial condition that y at the point x0 is equal to y0. The solution satisfying this initial condition, that means the graph of the solution contains this point, goes through this point xy. So the solution may look like that. So what does this theorem exclude? What is not true? Say the solution is unique. So what is not possible under this condition is that if we have the rectangle here and hit a point, it is not true that these two functions are solutions. because then we would have two different functions, two different solutions. And the theorem says that the solution is unique, there is just one solution. So this is not possible. Also, the theorem says that the graph runs from the boundary to the boundary. So if we have here the point, the graph of the function may look like that. It doesn't stop here, it goes up to the boundary. It doesn't have to go to the right hand side. It may well go to here. So it is not guaranteed that for these x values the solution exists. If we have the initial condition here, it may go here. Or alternatively, it may go like that. Or still, another possibility is that it goes through this point, but it may look like that. So the domain of definition does not have to be the interval AC entire interval. This theorem has quite interesting philosophical consequences. When Isaac Newton and his colleagues and friends and followers discovered this part of mathematics, when they discovered the motion of Earth and other planets around Sun, then as from the mathematics, it looks like that given the initial condition, all the future development is completely determined. So people were asking, if the world is described by some equation like that, does it mean that everything is predetermined? We have no free will? Everything is governed by some physical equation, by some physical law, and the set of the universe just after the Big Bang? Quite interesting questions. And the solution is that physics and mathematics are not the reality. They describe reality quite well, but not perfectly. This is just a description, this is just a model, this is just a simplification. The world is fortunately much more complicated and much more interesting.